Okay, we're starting now. So what we're having a look at now is limits. So it's not as in depth as what you might have seen on other courses. A little bit more basic. So we'll have a look at some examples of when you do and don't have a limit. So before we get started on that, just know that you have a limit when you have something which is convergent. And we remember convergent as a word, yeah, from earlier last week, wasn't it? Convergent. So, for example, if I have something like 1 plus 2 plus 4 plus 8, etc. This is, if we were to continue to infinity, this is divergent. Okay? But if I did 1 plus a half plus a quarter plus an 8, and we were to continue to infinity, that would be convergent. You would actually get an answer out from that. Can anybody see what these all add up to? No, not that one. 0 would be quite no. So you can visualize it too. Have a look at this. So there's 0 and there's 1. So you have 1 plus, and if I mark off 2 here, a half. So that would be this much, yeah? And then plus a quarter, which would be that much. And then plus an 8 and plus a 16th. So if you were to continue this forever, eventually you would add up to a total of 2. So you would say that 1 plus a half plus a quarter, etc., has a limit of 2 in this example. Now don't worry, I'll show you in a few minutes how to calculate exactly what the limit will be. But just for now, we're just clearing up some vocabulary. Limit, convergent, divergent. So just make sure you have the meaning clear in your head for those 3 words, okay? And we'll have a look now at the first example. So our first example is to check if a series is convergent. Can I scroll down? Yeah. So imagine you have Sn, a geometric. Oh, well, I should actually say S infinity is never convergent if it is arithmetic. And you can see why. Like, if you keep adding some arithmetic sequence together, like let's just say 4, 6, 8, I mean, there's no way that this could not be infinity, because the numbers are getting bigger, you know. And you might think, well, what about if I try adding together numbers which are getting smaller, like say 4 plus 3 plus 2 plus 1 plus 0 plus minus 1 plus minus 2, etc. What would that become? Minus infinity. So there's no way that an AP could have a limit, but a GP could. So S infinity is never convergent if it is an AP, but could be convergent if GP. So let's see what we would need for that to happen. So we know that Sn equals A times 1 minus or power n over 1 minus or. And we'd like to know what is the total sum, the infinite sum, the limit, which we're going to represent by S infinity. So add everything up, the whole lot. Okay? So that would be A 1 minus or infinity over 1 minus or. Now, what the heck is or power infinity? 2 things could happen here to or power infinity. It could have 2 different values. What do we think? So, well, if or was some number like 2, What would be 2 power infinity? Infinity. 2 by 2 by 2 by 2 by so on. What about if r was something like a half? It would be 0. Because if you multiply a half by a half by a half by a half, it keeps getting smaller. You get a half, a quarter, an eighth, a 16th, and so on. So what happens here really depends on what r is. If we don't want infinity, which we don't, then we need the r to be some number between -1 and 1. As long as it's a fraction like this, then r infinity will become 0. And so we get this formula. The limit is a over 1 minus r. Now, before you write that down, we can test that formula out with the example I gave earlier. In this one here, what's the a? 1, and the r? A half. Yeah? So, the limit should be a over 1 minus r, which is 2. Okay, so the formula works to give us the limit. So this is our first formula. This is the formula for a limit only if, of course, it's GP with the r between -1 and 1. There's no limit if the r is more than 1. Yeah. We got that? No? Okay. Yeah? We got that? Okay. What I would like you to do now is just to take out your calculator and using the calculator, can you tell me what this okay, now before the calculator, just a quick example. This would be an exam question for like 1 mark only. A question something like 5 minus 25 over 6 plus 125 over 36, etc., etc., etc. And the question for like 1 mark, maybe 2 marks is, does this series have a limit? So the question is, does it have a limit? Now, it's GP. What's the r here? You might need your calculator actually to help you out. Yeah, -5 over 6, good. So, does it have a limit? Well, think back to the formula. Yes, it has a limit because its value is between -1 and 1. So therefore, it converges to limit since the r, which is equal to -5 over 6, is between -1 and 1. So I think this maybe is a 2 mark question in the exam. You would get 1 mark for this and 1 mark for this. So that's our first example. And since it has a limit, we should calculate it. So using the formula, S infinity equals A over 1 minus r. Thank you. 30 over 11. So this is the limit it's trying to converge to when you add the terms together. Yeah? Okay, next now. Can I scroll down? Yep. Right, so using your calculator, I want you to try and figure out what the limit of this sequence is, this recursive sequence. The next term is equal to -1 plus 2 over this term. And you can start with -1. And you remember the trick I showed you on the calculator? Yeah? I want you to see if this is moving towards any particular value. I think it should be convergent. Let me open up the calculator too while you're doing that. You remember how to type it in, yeah? Convergent? No, it's not convergent. Is it convergent? Yeah. To what, do you think? To -2 it looks like, yeah? Let's give it a check here. So where am I starting? -1, isn't it? And then -1 plus 2 over -1. So then we jump to -3, -5 over 3, and yeah, it looks like we're clearly hovering around 2, doesn't it? So there we go, we've reached it there. -2. Okay. Now that was nice to do because the limit was nice and clear, wasn't it? But what about if we had an example where it's like 1.6 something? You know, something like this. I'll show you how to do it for this one, and then we'll look back at that one we did last time, the answer that had the 1.6. So it was a similar formula. I think it was 1 plus 1 over xn, but we'll look at this one first. So we want to know what's the limit here. So the trick is to make n go to infinity, because that's what you're trying to do, isn't it? Make n go to infinity. So what does xn plus 1 become? That becomes x infinity. That becomes the limit. Right? And what does xn become? Also x infinity. Yeah? Just think about this. Like pick n as a large number, like 1,000,000. This would be x 1, 2, 3, 4, 5, 6 equals -1 plus 2 over x 1, 2, 3, 4, 5, 6. As I make the n bigger, both of these guys move towards the limit. Now, who is moving slightly ahead? Who's getting there? They're the first one. But I mean, you notice on your calculator, as you move further out, the difference between the neighbours becomes really small. You know, like what was the number before this? 1.999999. So, although these guys are different, the difference is not important. It's so small, it doesn't matter. And in fact, when it goes to infinity, they both become the same thing anyways. Let's solve this now. This is what we want to do. How can I solve this? What should I do here? We're solving for x. If it helps you, you can think about it like this. X equals -1 over 2 plus 2 over x. What should I do to solve this? Multiply by x, yeah? So that becomes x squared minus x plus 2. Yes? So that becomes x squared plus x minus 2 equals 0. So what are the solutions here? X plus 2 and x minus 1. So you have two answers here. The limit could either be -2 or 1. But there's only one answer. There's not two. And we know which is the right answer. The -2, because that's the one the calculator was trying to move to. Yeah. So this is the answer. It's exactly -2. Now this one is easy because, like I said, you could kind of see that the limit is -2 already. But what about an example where it's not so clear, where you're getting an answer of like 1.6 something? So let's have a look at that one now. Can I scroll down? Yeah. So can you take out your calculators again and have a look at 1 plus 1 over xn. I think that was it. Starting at 1. I think you'll find it does have a limit, but it's not clear exactly what the limit is. If you put that in on the calculator. Yeah, it's something like this. But you have to be careful, because in the exam, they could ask you for the, not just in this question, but any question, they could ask you for the exact answer. Now, what does it mean to ask for the exact answer? Does that mean the decimal or the non-decimal answer? It's the non-decimal answer. So if you were to write this answer down, even if you wrote the whole answer down, it's not the exact right answer, because there could be numbers here which you missed, right? You don't know that it stops at 9. It's just the screen ran out. There could be more numbers here. So we want to get the exact answer. Let's look at that. So just to be clear before going on, if x is equal to root 2, this is the exact answer. And then if you put this in on the calculator and write down 1.4141, that's not the exact answer. That's only, an approximate answer. So we want the exact answer here. Okay, let's use the same trick we did before. Make n go to infinity. So this becomes x equals 1 plus 1 over x. That becomes x squared plus x equals x plus 1. And this becomes x squared minus x minus 1 equals 0. Does this have factors? No. We have to use the formula. X equals minus b plus or minus square root b squared minus 4ac all over 2a. Now again, it has two answers. It has the answer 1 plus root 5 over 2 and 1 minus root 5 over 2. Now this answer is positive and this answer is negative. When you are using your calculator, you notice how the answer is definitely positive. We don't know exactly what it is, but we can be confident that's a positive answer. So which of the two do we take here? This one here. Now type this in and get the decimal value. It's the same, isn't it? Yeah? But this is the exact answer. Whereas what we did before was only an approximate answer. Yeah? Okay, so that's another example. That's a good exam question, because this one, you can't use the calculator to get the answer. You're forced to use this method. So it's a good exam question. Because in the previous example, well, it's gone now, you could just use the calculator. Yeah. So can you write this one down carefully? The limit x infinity equals 1 plus root 5 over 2. Okay. You got that? You got that? Yeah? Yeah? Scroll down. All right. Again, you can use your calculator. Here's a sequence t. Tn equals 6n squared minus 7n plus 8 over 3n squared minus 5n. So I want you to calculate a few terms for me. You can give me it as a decimal, okay? Give me the first term, the 10th term, and the 100th term. Well, actually, yeah, the first term. So we put in n as 1, and then 10, and then 100. So six times 1 squared, 1 squared, minus 7 times 1 plus 8 over 3 1 squared minus 5 times 1. So did you all get minus 3.5? Yeah. Next, the 10th term. Just put in tens. That will be, in this case, 2.152. The 100th term. 2.010, and one more, 1,000th term. I expect this to be even closer to 2. Whoa. Yeah, 2.001. 001, yeah. Would you say this sequence is convergent? Yes. And what would you say the limit is? 2. Eventually. The limit is exactly 2. Yeah, the limit. Yeah? Is okay? Are you having calculator trouble? No? Okay. But just like the last question, maybe it's not exactly 2. You know, maybe we need a method that can give us an exact answer. So let's have a look at how we can get the limit of this guy. There's a trick here to calculating the limit. I wonder if anyone knows what the trick is. There's a way to simplify this to make it clearer to see exactly what the limit is. Does anyone know the trick for these ones? No? What you do is you divide everything in the fraction by the biggest n power. So what's the biggest n power here? It's n squared, right? So we divide everything by n squared. So what will we get? We'll get 6. What's next? Minus 7 over n. Yeah? Yeah. Plus n squared. And then on the bottom we get 3 minus 5 over n. Okay. And then what you do is you make n go to infinity. So 6 is still 6. But what's 7 over infinity? 0. And 8 over infinity? Also 0. And then 5 over infinity. So you have the exact answer. It's exactly 2. Yeah? So this is a very nice little trick to manipulate it to get the limit out exactly. This looks like something nobody's seen before. Is that? Yeah? Nobody's seen this before. Okay. It does come up in a calculus chapter. Yeah, you think you've seen this? Yeah? You were just too shy to tell me? No? Or you didn't remember? Let me give you a quick one just to make sure you got it. So let's say you have something like, I don't know, 5 plus 6n over 1 plus 5n. So this has a limit. I'll give you a few seconds to calculate the limit. Six over 5. Yeah, what do you divide by? You divide by n. Yeah, so this is 5 over n plus 6 over 1 over n plus 5. Then you make n go to infinity. And so this will become 0 plus 6 over 0 plus 5. So the limit is 6 over 5. Yeah? Okay, there's only one more example of limits to look at now. So if you can write that one down, we'll do the last example. You got that? Yeah? Everybody has that? Yeah? Let's scroll down a little bit. No, let me do something a little bit different. 4, 5, 4, 5, 4, 5, etc. So does anyone know what the name of this type of number is? Recurrent decimal. The numbers keep repeating themselves. Okay. If you have a recurrent decimal, it's always possible to write it as a fraction. It's always possible. Now let me give you a very simple example. Here is the simplest recurrent decimal. The first one you learn about in elementary school. What fraction is this? 1 over 3. Okay. Now you didn't calculate that. You know that. You learned it in elementary school, right? What we would like to learn now is how can you take any recurrent decimal and write it in fraction form. Yeah? How do you do it, Jeff? Yes, there are two ways to do it. One by separation and another by using a series. So I think in the exam, because this question always comes up in the question about sequence and series, they want us to use the sequence and series method, but I will show you the separation method as well. So let's have a look at the first method. So you have 0.454545, etc. You can split that into 0.45 plus 0.0045 plus 0.000045. Is this what you were thinking of? Ah, so you don't know the other method then, do you? Okay, good. So if you look very carefully at what I just did, you realize what you have here is a geometric progression where A equals 0.45, and be careful, what is the OR? Not 100, 1 over 100. So this equals S infinity, and we have a formula for it, don't we? A over 1 minus OR, 0.45 over 99 over 100, 5 over 11, is it? If you type 5 over 11 in, you should get 0.4545. You do, yeah? So maybe some of you, I know at least one person has. Have other people seen this method before? Yeah. So I said there is a second method, but I don't think this is really what they want for the exam. However, when I think about the exam question, they never specified the method, but it's usually in with the sequence and series question. Does anybody know of another method for this? Yeah? What do you do? Good. And then what do you do next?
And then something to 100x, and then you make it.
That's it. You make a, yeah, okay, I think you got it there. Yeah, so you write x equals 0.4545, and then you multiply by 100, and the reason for 100 is...
You want to get rid of
the
4545.
Yeah, well, it's because it's twice, yeah. You want to move one of them out. So if you multiply by 100, you get 45.4545, and so on, etc.
And then you subtract 100.
That's it. Or maybe what I'll do is I'll just write this as 45 plus 0.454545, and then you realize this guy here, that's x. So that's 100x equals 45 plus x. So then that's 99x equals 45. X is 45 over 99, which is 5 over 11. Same answer. Yeah. Isn't it just? Isn't it just? Okay. Better. It's real, you know. Okay, so that's limits. I'll just say, yeah, we'll go with maybe, let's see, 1A and then D. Now, number 2 is fairly important for the exam. We'll go with 2D and maybe K. 3A is enough, and then 4L and M. This one is nice. I like that one. All right, we can get a start. There's 10 minutes, so you should get them finished now. We'll put the light back on. Yeah, you wanted to do that one first because I said it's nice. Yeah?
The answer said 1, then cool.
Yeah. Is it not? The answer's 1.